So hi everyone, I'll tell you about myself right now while I'm setting it up, just to save some time because I know we all are hungry, and I'll try to finish on time, although I technically have half an hour, but we can definitely do a Q&A during lunch, so just find me, ask me questions and all of that, so saving time. What else? So my talk will be a bit different from everything else you've been hearing here. So my background, I'm a social scientist. I'm a PhD student in sociology at the University of Iowa. And I'm here to talk about my very, very work in progress. And it's kind of like, it's building on two talks that I heard today, and hopefully you did too. So kind of building up on Ian's keynote about citizen science, what can you do with data, how you can solve specific problems. And although his examples were beautiful, you just program a drone, or you just, make people go vote. But actually in real life, and I wanted to show you here today, is that it's not that simple. It starts from like tiny steps, and you'll see where I'm at. It isn't beautiful, it's complicated, and sometimes I don't know what to do, and it takes a lot of time to actually deliver that final project. And what I wanted to take away from this talk, not necessarily I don't know what I'm doing, but kind of, you also can do it. I can do it, you can do it. I've been programming and coding for like a few years now. Like I usually do R, kind of switching to Python now, or like using both. But I'm not a computer scientist. I don't have that background. I'm a social scientist. So I can do it. You can do it. It'll be great. This is the title of my talk. Not the greatest title. I do not know how to name my project right now. And this is actually a summary for all of you visual learners. So what I do actually, I need my notes. In this project that I'm going to talk about, I use Python, the snake Python, to to process a corpus of a text and to look into group dynamics and group networks of co-working behavior networks. So that's like the network there. And the group that specifically I'm interested in are people who work and live in isolated, confined, extreme environments, or ICE for short. Or so you think about people who live in Antarctica, right? Who study, like researchers, you spend whole winter together, you hate each other, but you have to stick together. Or in the future, 4 years, as Pence promised, moon base, right? So people will be living there at some point, right? You can't leave. You have to work and live together. So these groups are different from your everyday working group. Yes, that's what I study. Groups in space or similar environments. I go through text records. I use Python, and in the future, my research should help people, not necessarily get on Mars, but actually get along while getting there. So that's my talk summary. I'm going to spend quite a few minutes actually just explaining why is it important, because we all know air quality is important. That's something we breathe, that's something we encounter every day. Again, kind of linking back to keynote today. Here, so a lot of times people are saying like, well, what? Like, why? So I'm going to give you some background, why is it important, and like what actually I'm studying and how do I study these groups. And then I'll talk about challenges that I have now and some solutions that I'm looking into. Actually, after Sharuna's talk today, I think I figured out some good things. So thank you. Cool. So this is a quote from Canadian astronaut David Saint-Jacques. He's currently in ISS, and this is us, kind of explains, why do we need to study groups like that. I'm not going to read that. You can see it yourself. Another example, maybe you've heard about it, an example of what happens when tensions are so high and you can't leave. What was like half a year ago in Antarctica, two Russian researchers got into conflict, and one stabbed each other, allegedly because the one who was stabbed was telling ending of each and every book that the other was reading. And it's, you know, it's Antarctica, it's winter, nothing else to do, you're stuck with these people, like really, really annoying, so you take out a knife. And something that we want to prevent, right? So that's something, you know, kind of one reason why we study that. And when we work in groups, we are different. Like we all individuals, we all different, we come from different backgrounds, and studies do show that heterogeneous groups or groups formed from people from different backgrounds, they perform better because, you know, we have different approaches to the same problem. However, differences also create tension. And like specific difference between people that I'm looking in my research is gender, because there's something that we see every day. There are men, there are women, they're genderqueer and all of that. But in this case, I'm just taking the binary woman and man for simplicity's sake. So just tiny bit of statistics about women and space science and space research. Only 11% of all people, all human beings that ever been to space were women. So we are really underrepresented minority there. The same goes to any STEM. Like, look around, you know, how many women do we see here, right? We can count them like one hand. As people, we walk around with a lot of stereotypes in our heads, and that influences our behavior. And I'm cutting a lot of theory here, but just believe me when I say it, it's true. Stereotypes do influence our behavior, and especially when we are in very gendered environments. For example, as a man learning to knit, you'll have way more pressure put on you, and kind of, because everyone was like, oh no, men can't do that. You weren't born to knit. You know, you can't. And so when you are in very gendered environments, gender becomes, we call it salient, and stereotypes about gender behavior kind of plays even a higher role in people's expectations and you know, how they make decisions and so on and so forth. And there's research on the specific environment, you know, in isolated, confined environments, that men and women experience differ. For example, women leaders are valued less. They say that they just don't perceive less support from their followers, or like, let's say if they are in command, people, okay, they still listen to them, however, they will sometimes talk back or just really not value them much. And at the same time, women are expected to do more emotional labor, kind of, you know, like keep the crew together because you like motherly, you can do this, it's like awesome, kind of keep everyone happy. So anyways, like, I don't want to go over time, so women and men experience differ. And a lot of times people do attribute it to personality differences or just character differences. So this is, but as a sociologist, I want to see maybe there's something more to it. Maybe women and men experience things differently in a structural way. Maybe there's something, maybe there's a pattern, right, across different areas and across different crews. Here, I just want to mention quick, and one more thing. A lot of studies that's being done on small isolated communities and crews, they have very small sample sizes because, well, again, there's not many groups like that, and so yeah, you don't have like high statistical power, and you cannot really detect like overarching patterns. It's harder to do. So this is why I want to look into more groups and in more structural way. So yeah, so this is kind of, I was building up to this point. You know, remember, as a scientist, as a citizen scientist, there's a problem. You know, I want to find, is there a pattern of like specific hierarchy across groups, right? And if there is, does gender has to do anything to do it? Is it related to gender? And so then I go to data. And how do we study groups? How do we study space on Earth? There are specific facilities called space analogs, or you can use groups in Antarctica or any place that kind of approximates the idea of being isolated, being in confined environment, like really rubbing shoulders together for a while, and also for a longer period of time. So my data comes from one of those space analog facilities. It's called Mars Desert Research Station. They've been in operation since 2001. They have 2-week rotations, short, but it gives me a lot of crews to work with. 6 people in a crew. They have official roles assigned to them, like commander, second in command, crew engineer, crew scientist, and so on and so forth. And those roles are kind of consistent across, so it also allows me to compare them. At this point, there were over 210 crews that completed simulations, and during their full simulation mode, they don't go outside without a fake spacesuit, so they mostly stay inside and like really try to approximate Mars as close as possible. And that's why they are in Utah desert, because you see, even the landscape looks like Mars. So this is data that I'm working with. And specifically, so I was thinking like, so how can I measure hierarchy in any way? So I selected one specific way. Like, so spacewalk, as I said, they're like very important and exciting part of simulations. That's where you put like fake helmet, you like stay in the airlock for like 20 minutes, and then you will like walk around with like helmet on your head. You can't breathe, but super exciting. And they do that in every simulation. It's something that people are very exciting. And if you Google MDRS afterwards, you'll see there's a lot of selfies with them in spacesuits and stuff. So this is something that I wanted. So I said like, okay, I'll just use these as my proxy for their co-working habits and so I can detect hierarchy. And good thing about these people, about these folks, is that they document everything, and crews are required to like file daily reports. So I can go through the reports and then actually get people who are working together. And then I can get sociodemographic data from BIOS kind of to see whether, like as a control variable. So my main part of my analysis is social network analysis. This is how I see like who's working with whom more often and on more spacewalks. And like basically the idea is like the more central you are, kind of you have the higher hierarchy within the group, and that's like the unofficial hierarchy that I'm looking at. And I want to see whether gender can predict the most central person and controlling for other demographics. So in other words, my problem becomes like this. So I have to get from text like this, which is like EVA reports. There's like some names here: Nancy Wood, Jonathan Clark, and Stan Pekonsinski. So I need to get from this, and then I have to go through their biographies and kind of see like who they are. So I have like two bodies of text, and I need to get to something like this. So this comes from my pilot data that I hand-coded, but just kind of to show you where I need to get from like point A, question mark, point B. So these are co-working networks, right? So these people, like the thicker the tie, the more times they work together. And like, this crew, the most central person is a male commander. And like we have two women that were kind of, you see in the co-working network, they kind of like on the periphery, means that they were kind of not included that often in these activities. So this is my problem, this is where I need to get, and what do I do about it? So, as I said, I did a pilot study. It took me a month and a half to just like really read through, make adjacency matrices, and then calculate everything. So it's 1 month and a half for like 30 crews, which means I need another year or more than a year just to really get this data like fixed and cleaned and actually be ready to go. Or I need about 5 undergrad assistants, and I don't have. And I want to graduate, so I don't have time, and I don't have undergrads to work for me for free. So what I do, I need to actually use Python for that. And so I started working on it. I thought that I could show you a bit more stuff, but I just ran into more things than I thought. So first thing is like the text is very unstructured. The reports are like all over the place. They don't have one form. So I can't just like, take beautiful soup, parse it out like, first line, all the names, second line, blah, blah, blah. I can't do that. Texts do not follow the same order. Also, I do have non-English names, and actually today I might try a different packages for, not today, later I might try different packages for named entity recognitions, but so far like Spacey or NLT key like really misclassified my persons. I got a lot of false positives and false negatives as well. Also, I have another thing that names are misspelled, and sometimes they just use nicknames. They just come out of nowhere. Also, they're like first-person reports. Let's say like I and that did that. So I need, in the end, I need to connect that I to the person who wrote it, and then sometimes they file more than one at once. Sometimes they just don't do separate crew reports at all. and they just like embed it somewhere else. So these are kind of like just a few of the challenges I'm working through. And again, this is kind of to show how this data science or citizen science projects are, how do they start, how messy they are in the beginning. So what I'm going to do, like at this point, what I'm thinking, I'm going to use the cruise bios. I'm going to show you in a sec how they look like, just to remind you, to train my named entity recognition models, because they are like a bit more structured. There's usually the names are capitalized and names are in the beginning of each paragraph. So it will be easier to actually parse the text and get them, and then and then assign a label to them, and then use it as use it for later for like tagging the rest of the text and getting the names out of it. So that's kind of like one point that I'm going to work on, and I'm thinking on. Again, like I'll probably have to get all the eyes as well from all the reports, and then connect it to the author. I'm still thinking, trying to figure out how to work on that part. Another thing that I need to get, so the structure, thinking about the report structures as well, I probably need to get names that are in one sentence, because sometimes they just mention random people for no reason, or like just reminiscing about something in the past. And that's something, obviously they were not there, they were not working together. So I'm going to, so my algorithm will actually look for names that are in one sentence. That's something that will say like that, and that person, we did this together. So also I'll have to like look for EVAs for all the other reports and seeing whether they mention that, and then go through like the same tagging again, and then in the end kind of remove the remove the duplicates. And then all of that will have to be exported to like a nested list of names, and then like made into adjacency matrices for social network analysis, and yada yada yada, and at some time I'll have some success. So this is what I wanted to talk to show you like how the process starts. Where do you go? You have a question. What do you do? Where do you go from there? How do you find data, and how do you think about it? Any questions, comments? We have 5 minutes before lunch. Yes.
So how many reports have you got?
I have about like 4,000 or so. So like it's not a big data in your big data sense, but it's too much to read manually.
And the one report is?
It depends. Sometimes.
Page.
So sometimes it's like this, these are like 2 reports, right? Sometimes they are like very long narratives. We did that, like some embedded pictures. So again, there's no structure to that. So it's like long, yeah.
That's good. So in custom interactions, how do you distinguish between the various ways interacting? So not necessarily someone's dominating, but or like them, or.
Yeah. Okay. So this is one of the kind of like downfalls of working with secondary data, because I don't see the decision-making process itself. But I'm looking, so the idea is, the theory behind it, like this, so that people, what I'm looking into co-working patterns, who's working with whom, that's my interaction. If you worked on a team, like let's say you went to like spacewalk together, like which one, like, yeah, like let's say like these 3 people, they went together, so like that's an interaction. And like, so the ties are like the more times you worked together, like the more times you had an interaction. That's my measures for this. Yeah.
So if there was no hierarchy between male and female, you'd expect all those scores to just be equal because it's controlled for the role?
Yeah, it's now controlled for the role. And like, so in the future when I have more data, I can put in more other sociodemographic controls. That's another reason why I need more data, because I want to control for education, I want to control for the previous experiences, and all so on and so forth. So far I'm just controlled for the crew role. Yeah. Oh, sorry. Oh yeah, go ahead.
And are you planning to sort of not control, but see whether there's a tendency dependent on age or something?
So no, that's a control variable. Yes, I will put in age and their time and career. More likely, I don't have their age a lot of times. Right. Whether you're a student, whether you're like an experienced person, and because that's also a variable that will affect the hierarchy. Of course. No, yeah, that's one of the things that I'm going to put in. There was a question.
Yeah, it was not a question, it's more like a suggestion.
Mm-hmm.
One of the problems why you have many false positives and false negatives when you are doing a name density recognition in spatial and LPK is that you are trying to do it bottom up. Spatial is like looking for a token list which resembles a name.
Yeah.
But you are trying to solve a different problem. You know all the names a priori.
So just like regex.
Yes, and no, actually you can do that, or you can use more sophisticated tools. For instance, the same space has phrase matcher or token matcher. And just if you give it a predefined list of persons, you can just find them, and it actually will be, it can give more flexibility even than simple regex.
Well, yeah, but to get predefined lists, I need to get those names first.
Yeah.
Yes, so yeah, that's part of it. That I need to get names first, and then when I have the list of names, so so then either the tagging or just like parsing, like if lists and stuff like that. Yeah.
So when you have documents that are like direct speech is it direct speech when they say I?
It's
not direct speech.
Yeah.
Okay. What techniques are you?
So I'm thinking.
Using to figure out what it stands for?
Yeah. So no, that's something that I've been like thinking about it as well, because a lot of times. So I'll have to get kind of like select probably like the way I'm thinking. I'll have those text files separately, and then they'll have like probably additional like step to it. If it has an I, like if it has an I, it has to, and then I have to get the author's name, as part of
Do you have metadata or?
So
is it available?
a lot of times they do have it, like who reports it. Again, like sometimes they don't as well. So
is the person reporting normally one of the people on the EVA?
sometimes. No, so yeah, that's the thing, because at first it's like yeah, it's such an easy project, great, easy, but then it's like oh no, there's no structure to it. There's humans, we are not robots. Okay, so I think we're out of time. Thank you everyone for listening to me, and go do your own project. It's not that hard. Just it's hard to start. It's messy for like a year or 2, 3, 4, 5. But then you have a result, and you can actually influence the future. Yeah. Thank you.